Hello everyone and welcome. Today I would like to talk about move zeros. This question will involve array transformation. An example is following. Let's take a closer look at this. Specifically, this question provides you an integer array, asks you to move all the zeros to the end of it while maintaining the relative order of the non-zero elements. So how can we do that? Actually, this question is more about moving non-zeros. This is because the zeros do not really have a relative order. In contrast, the non-zero elements do. You may be able to come up with an easy solution like this. So first of all, we pre-populate the result array with zeros, and then we iterate through the nums array. And when we encounter a non-zero item, then we insert that item into the result array one by one. However, this solution made a copy of the nums array, but the question asks you to do this in place without making a copy of the array. So this one does not work, but we can modify it to make it work. On the other hand, it's also possible to generate an one-liner solution using the sort method in Python. But this solution has a time complexity of O n log n. Can we do better than this? One possibility to do in-place operations is to use swap in this question, where swapping in a non-zero item from a higher place means to swapping out a zero item from lower place to higher place, like this one from a higher index to a lower index means 0 from a lower index to a higher index. With the background introduced, now let's write the code. So first of all, we'll initialize a variable, we call it insert position. And this variable is a pointer for inserting non-zero item in the nums array. Okay, and then we want to traverse through the nums array. Okay, traverse through the nums array. Okay, at each iteration, we will check whether nums I equals to 0 or not. If it's 0, then we will hold insert position to be the same as it points to a 0 item, which can be used for swapping in and non-zero item. And then we will move I forward to the next place. Else, if the nums I is not 0, then we will check if in the position is less than I, because if in the position is less than I, it means we can swap a non-zero item to insert position and a 0 item to I place. Okay, so we will do a swapping here, and nums I nums insert position swap with each other. Okay. Afterward, we will increase the insert position, so it will point to the next zero item for insertion next time. Okay, and we also need to increase I as well. But if the insert position and I they are the same, and in this case, both of them will advance to the next place, but no swapping will be taking place. Okay, when they are the same. Okay, and both of them are pointed to non-zero items. Okay, but the same non-zero item. Okay, now let's test this code to see how it works. We submit, it's pending, and done. So it passed the test. Success. Very good. Now let's revisit the code. You can see it can be simplified. So if we move this insert position here, you can see they are the same. So we can just use one of them, and you can see this I plus equal 1 can also be used just one time, like this. Okay, and since this is nothing here, then we will just simply do this. Okay, so this is simplified code, and we can also test this again. We submit, and done. So some improvement here. Very good. Okay. Finally, we can analyze the code for complexity. So this code has a time complexity of n since we traverse through the nums array in a linear way. And for space complexity, it will be O1 since we modify nums array in place and use constant space variables otherwise. And the code above is the optimized condensed version. Okay, so that's all for this question. Hope you find this video to be useful. Please subscribe for more videos. Hope to see you next time soon, and goodbye.